A beam of protons traveling at 1.2 kilometers per second enters a uniform magnetic field traveling perpendicular to the field. The beam exits the magnetic field, leaving the field in a direction perpendicular to its original direction. The beam travels a distance of 1.18 centimeters while in the field. What is the magnitude of the magnetic field? Here we have a beam of positively charged particles moving in a magnetic field. As a result, there is a magnetic force acting on these protons. The protons move along a circle of radius r with a velocity v tangent to their trajectory. According to the right-hand rule, the magnetic force acting on the protons is oriented perpendicular to both the magnetic field and the velocity towards the center of the motion. The problem gives us the length of the path traveled by the protons, 1.18 centimeters, their speed, 1200 meters per second, and asks us to determine the magnetic field in that region. The length of the path traveled by the particles is nothing else than a quarter of a circle. So we can write that the length of the path S equals the circumference of a circle 2 pi r divided by 4. From this equation we can find the radius as 2s over pi, and s is replaced with 1.18 centimeters, and using a calculator we get that the radius is 0.751 centimeters. Now the force acting on the particles is the magnetic force, which can be calculated as the product between the charge, the velocity, and the magnetic field. Because this is the only force acting on the particles, we can also write that the force equals the mass time acceleration from Newton's second law. But don't forget that because these particles are moving in a circle with constant speed, the acceleration is a radial acceleration, which can be calculated as the square of the speed divided by the radius of the motion. If we take the expression for the acceleration and replace it back in this equation for force, we have that the product between the charge, the velocity, and the magnetic field equals mass, and instead of the acceleration we write v squared over r. And from there we can find the magnetic field as mass multiplied by speed divided by charge multiplied by the radius. All we have to do is plug in the numbers. And the mass of the protons is 1.67 times 10 to minus 27. The speed of the protons is 1.2 kilometers per second. Don't forget to convert into meters per second. That's 1,200. The charge of the proton is the same as the charge of the electron, except that it's positive. So that charge is 1.6 times 10 to minus 19. And the radius we just found to be 0.751 centimeters, which have to be converted into meters, and that is 0.00751 meters. Using a calculator, we obtain that the magnetic field in that region is 1.67 times 10 to minus 3 Tesla.